For 27 years, a specific mathematical mystery frustrated the brightest minds in theoretical computer science. Since 1999, the solution to this problem remained blank. Then, an unreleased internal model from OpenAI, codenamed Astra, produced the solution. The reported cost in computing power to generate that definitive answer was roughly $2,000. This leaves us looking at two very different realities. We are either witnessing a piece of corporate marketing, or we are seeing a drop in the cost of solving the unsolvable. Past mathematical models, like the ones that win standard Olympiads, work because they train on known competition structures with existing answer keys. Astra, however, solved open questions where nobody knew the final answer. Because the output is original and the compute cost is low, the argument that artificial intelligence is strictly a remix engine for human knowledge is harder to maintain. The persistent flaw with modern language models is that they confidently make things up. They hallucinate facts, which forces researchers to treat their outputs with suspicion. The countermeasure to hallucination is Lean-4, a mathematical verifier. Using a concept called zero sorries, every single micro-deduction must be explicitly proven. You cannot use plausible-sounding words. The compiler either accepts the entire sequence or it rejects it. Because Astra's proofs were successfully verified by this logic, humanity is no longer the sole gatekeeper of the truth. The proof validates itself. The headline achievement in this dataset is the first explicit construction of a non-sophic group. To picture the non-sophic group problem, imagine trying to build a perfectly smooth, infinite curve using only rigid, finite bricks. Mathematicians wondered for decades if a structure existed that refuses to be approximated by those finite systems. Astra found one. It didn't stop there. Volatile pushed the high-dimensional sphere packing problem past a 46-year barrier. It established new asymptotic bounds. It resolved Erdos problem 183, claiming a counterexample to Khanaz's conjecture. It also produced stronger spherical codes. The reaction from researchers was immediate. Fields Medalist Timothy Gowers stated he would recommend one of Astra's proofs to a leading journal without hesitation. The machine's logic was so dense that 9 mathematicians, including Gowers, had to write a companion paper spanning 249 pages just to translate the AI's logic into a format a human could follow. The highest echelons of science are no longer treating the output as a novelty. They are parsing it like peer-reviewed work from a fellow theorist. But a closer inspection of the experiment reveals a more complicated picture. Critics like Derry Margus point out that being a narrow savant at abstract mathematics does not equal broad general intelligence. Then there is the $2,000 headline figure. That receipt only calculates successful runs, ignoring the financial drain of failed attempts. There is also manual human intervention to account for. OpenAI staff actively helped formalize Astra's raw outputs into the required code. Questions about attribution are also surfacing, with the sphere packing argument reportedly echoing the 2016 work of Stephen Miller. And because Astra remains closed source, independent researchers cannot test these claims. The mathematics produced may be verified, but the demonstration itself was curated, assisted by humans, and shielded from outside reproduction. Even with those caveats, theoretical mathematics is the source code for the hard physical sciences. The loop we just saw, where an AI searches for a valid path and a compiler verifies it, is exactly the same mechanism required for biological protein design, discovering novel new materials, and routing complex chip architectures. If a machine can reliably clear these complex formal barriers for a few $1,000s, the friction required to achieve a breakthrough drops. The time and capital needed for discovery shrinks. We have to decide what exactly we are looking at. It might be a highly engineered public relations stunt, or it might be the moment that formal verification became a scalable part of the scientific process.